Okay. That's what I'm looking for. Okay, so what we're going to look at today is we're going to be able to factor polynomials completely. So basically what we're going to do is we're going to put together all these different ways that we've been able to factor polynomials. And in some instances, we're going to complete multiple steps in order to ensure that we get the very simplest form of that polynomial. We will go ahead and work through some problems. But again, just some quick examples or some quick overview. Certain polynomials have formulas that can be used to factor them out. So some polynomials already come with predetermined formulas that we can use to factor these polynomials out. And we've looked at these already. The first one is the difference of squares formula. It basically says if you start with a polynomial that looks like this, then what we can do is we can factor it out to look exactly like this. And then what we would do is we would apply FOIL. So this multiplied by this multiplied by this multiplied by this multiplied by this. And that would give us our simplest form of that original polynomial. So that is the first way that we can factor out a certain polynomial. The next one is the one that we looked at on Friday, the sum and the difference of cubes. If we have something that looks like this, then we put it into this formula. Right, that's what we looked at. And if we have something that looks like this, oops, this is supposed to be a B. Then we would put it into this formula. B. Okay, and then lastly, if we have perfect squares, for example, if we had an expression that looked like this, it would get factored out to look like this. If we had something that looked like this, then it would get factored out to look like this. So these are certain types of polynomials that we have. Basically, if they follow these forms, then we have these specific formulas that we can use to factor those polynomials to the very simplest form. And so basically, we're using A and B. So this A would basically take place those places. This B would take those places. Right? Pretty straightforward. This A would mean this A, this A, this A. That's where I would put it in. This B, this B, this B, this B. So basically, I would just substitute those in, depending on what my expression tells me to do. So it tells me where to insert that A, where to insert that B. And then I would just do that. Okay. A, B. And so I can use these formulas to get these polynomials into the very simplest form if their original form comes in those highlighted terms. So if we see polynomials that look like one of those highlighted terms, then we know to use this formula. Okay, questions about this? No? Okay.
No, ma'am.
Okay, so we're going to go ahead and look at how to factor a polynomial completely. So factoring a polynomial completely is factoring it so that it's the very simplest form, so the very smallest that we can get it to be. So for example, if I wanted to factor this expression right here, there are multiple steps I can take. The first one I want to do is I want to take out the greatest common factor, right? 3 is the common factor that is shared here. And so I want to go ahead and take out that greatest common factor. So what I've done by taking away 3 is I've divided this by 3, I've divided this by 3, and I've divided this by 3. That gives me 3 with a shortened polynomial on the inside. So all I've done is I've taken out my greatest common factor, which is 3. Now that I've taken out my greatest common factor of 3, I want to go ahead and I want to actually simplify that inner polynomial. So now I want to simplify that inner polynomial. Basically, what we want that inner polynomial to be is I want it to be an expression, a factor, I want to create an expression where I can have the two values multiply to positive 3 and add to negative 4. So multiply to positive 3 and add to negative 4. And the way that I can go ahead and make sure that I do that is I can look at what we call the X method. The X method is pretty straightforward. It basically just says, on top we're going to put whatever A times C is. Here we're going to put whatever B is. Okay? On this side, what I'm going to put is what multiplies to, or here and here, I'm looking for factors. Hold on one second. Okay, so by using the X method, what we'll be able to do is we'll be able to factor that highlighted polynomial. So what you want to do in the X method is you want to multiply AC on the top, put B on the bottom. What I want here in these blue boxes, I want factors that would multiply together, give me the value, which is A times B, and add together, add to give me the value of B. And so this sounds a little bit complicated, but it's fairly easy. So we'll go ahead and look at it, the X method. So we're going to go ahead and solve for this. So A times C. So A, this is A squared minus B. Oh, AX squared minus BX plus, or minus C. Or here it's plus C. Okay, so that's the standard form. So what I want to do is take my A times my C. So my A is 1, my C is 3. 1 times 3 is 3. So I put that there, okay? Now I want to find my B. My B here is negative 4. Okay, so I've gone ahead and I've substituted those in. I've substituted in 3, which is 1 times 3, my A times my C, and then I've substituted my B, which is negative 4. Now what I want to do is find factors that when multiplied together will give me A times C, and when added together will give me B. The answer is 1, negative 1, and negative 3. How do I know that? Well, negative 1 times negative 3 is 3. That is A times B, right? A times B was equal to 3, right there. And negative 1 plus negative 3 is negative 4, which is my B. Right? And that's what I have right there, negative 4. Okay, so in the X method, what you want to do is you want to follow what this states right here. On the top, you have whatever your A times your C is. On the bottom, you have whatever your B is. What you're looking for in those blue squares is you're looking for factors that multiply to give you A times C and add together to give you B. Okay, questions here? Okay, so that's just an easy way to go ahead and factor. Now that I've gone ahead and factor this, I want to go ahead and plug it into my original expression. So I have 3 x squared plus, what this is giving me is it's giving me x values. So plus negative 1x plus negative 3x plus 3. So let me go ahead and color coordinate this so you can see where we got this. Okay, so what I've done is I've inserted those values where this negative 4x is to get this simplified expression right here. Okay, so I've inserted these values where that negative 4 is right here to get this simplified expression. Okay, questions about these steps so far before we move on to the next step? Questions? Okay. Now that we have this expression, what you'll see is we have what we looked at on Friday. basically we have a polynomial in the center that we can break apart and simplify further. So we're simplifying completely. So we're simplifying to the very smallest that we can. And so I'm going to go ahead and break this up. X squared plus negative 1x. I'm just going to write negative 1x. Same thing. Negative 3x plus 3. Okay, so I've gone ahead and I've broken that up into two smaller polynomials. Now, whenever I have polynomials like this, I know I'm looking for the greatest common factor. Here, I do not have two whole numbers, but I do have two x values. If I have two x values, I'm looking for the smallest of the two, which is x. So that is the factor that I'm taking out, x. Over here, I do have two whole numbers. And so I'm taking the greatest common factor of those primes. So negative 3, 3, negative 1 and 3, 1 and 3. They share that 3 in common, so I'm factoring out a 3. I don't have two x's, so I only need to factor out a whole number. And so now I have the expression x, the factor of x, and the factor of 3. Like this. So I want to look at this original expression again, moving it up here. What was multiplied together to give me my original expression? This expression right here. X, negative 1, x, and negative 1. Okay, and so there are my factors. I want to see, do I have any common ones? Yes, I do. So I only need to write that one once. And then I want to combine my other ones as a addition. So like that. And then I want to not forget that 3 that I had on this outside right here. Okay, so that is the simplest form of my original polynomial. So that is the simplest form. So basically what you should be noticing here is that what we're doing is we're putting together all these different ways that we went ahead and solved or factored polynomials. And we're putting them together to get the very smallest, the very simplest and simplified expression of our original polynomials. So normally if we were to just complete one step, for example, if I were just to go ahead and take out a negative 3, I would stop right there. If that was the only step that I needed to complete was factor this polynomial to where you're taking out the greatest common factor, I would stop right there. But because this question says factor the polynomial completely, what I need to do is factor it to where I have it in the very simplest form. So where I can conduct as many different types of ways to simplify polynomials and get it to be in the simplest form. And so in this one, I think what I did was I did about 3 different steps. First thing I did was I factored out my 3. Then I went ahead and factored my actual polynomial using the x method. Then I went ahead and used the greatest common factor method. And that gave me my resulting completely simplified polynomial. Okay? And so what we're doing here is we're basically saying how many different types of factoring of polynomials can we apply to one problem, to one original expression to get it to the very simplest form, to where I can no longer factor anything out of it. And so that's what we're going to be working on today. Okay, questions? So a lot of today is also going to be a review of everything we went through Unit 1 and Unit 5, or everything that we went through in Unit 5, because in Unit 5, we basically just learned about different ways to go ahead and factor polynomials out. And so today we're putting all together these different things, depending on what type of problem we have, to go ahead and solve. Okay. So we're going to review these different steps in the next couple of problems. So this isn't the first time you're going to see these things come up again. So let us go ahead and move on, okay? So again, we want to factor this polynomial completely, okay? Say that this is the polynomial I start with. Okay. What I'll notice here is I have a 2 expression polynomial. I know when I have a 2 expression polynomial, the easiest thing is to see if there's the greatest common factor I can take out. And so what I notice is I have 2 whole numbers. And so when I have 2 whole numbers, I want to find what primes do they have in common, right? So I'm going to go ahead and identify what primes do they have in common. And so I'm just going ahead and I'm factoring my original expression out to the smallest prime. So this is a prime number, this is a prime number, this is a prime number, this one, this one, this one, and this one. Okay, now let me work on 54. 54, 6 times 9, 3 times 3, 2 times 3, 2, 3, 3, 3. So I've identified all my prime factors in those original whole numbers. Now I want to see what they have in common. They only have in common 1, 2. And so that means I can factor out a 2. And I wouldn't factor out an x because I only have 1 x. If I had 2 x's, then I would factor out an x. But because I do not, I'm only going to factor out 1 x. So 2 x. Now I want to see, okay, now that I know that my factor is 2, what have I multiplied? Or what can I multiply to give me this expression? I can do 64x cubed, right? Because if I have 2 times 64x cubed, what that gives me is my original expression. Okay, so now I want to see, okay, now what can I multiply together to give me 54? Well, the answer is 27, because if I have 2 times 27, then I have 54. Okay, so this is where I'm at. This is what I'm left with. Now I'm here and I want to see, okay, can I go ahead and factor this expression out even smaller, even further? Because I need to factor it out completely, right? That's what it wants me to do. So yes, I factored it once, but I want to see, can I go smaller? So again, I'm going to see, do I have any greatest common factors? Or is there any way for me to go ahead and maybe create a sum or difference of cubes equation? Can I create a perfect cube monomial, basically? Okay, and so what I want to see is there a way for me to go ahead and factor this out further? And yes, there is. What I can go ahead and do is I can take out the cube of both of these expressions. So I can take out the cube. Okay, so now I want to see, okay, what has to be multiplied to give me my original expression? This one is 4x. How do I know it's 4x? Because basically what this is telling me is I'm going to distribute this here, and I'm going to distribute this here. 4 times 4 times 4 is 64. And that will give me x cubed. So that's that. Now, how about here? What's the cubed root of 27? The cubed root of 27 is 3. Basically, if I take 3 times 3 times 3, I'm going to get 27. Okay, so that's what I'm doing. I'm trying to see, can I create a perfect cube? Which I can. And so now that's my smallest expression. My smallest expression right now is this right here. Okay. Now what I want to see is, what does this look like? Well, this looks like I have a sum of a cube expression, right? Sum of a cube. It looks like I have the expression that follows right here. Right? Those look very similar. We're looking at that inner part, right? It looks like 4x cubed plus 3 cubed, right? It looks like it matches that. And so that means that I can plug in my a and my b into that expression. So a is 4x, b is 3. Right, I can see that a is 4x, b is 3. Now that I know that a is 4x and b is 3, I can plug it into that expression. So my a is 4x, my b is 3. So I'm just going ahead and substituting in my a's and my b's. 4x, b is 3. That was not, that's my fault. No, yeah, 4x times 3. And then 3. Oh, no. Okay, so now I'm putting in all the variables. Minus, plus. There you go. So I've plugged in all my A's and all my B's. Okay. And now I want to go ahead and see, can I simplify anything further? Yes, I can. I can go ahead and simplify this expression, and I can simplify this expression. So 4x plus 3. Here, I wouldn't be able to simplify. Here I can. This is basically telling me 3 times 4, so 12x. And this is telling me 3 cubed, so 3 times 3 plus 9. There I have my, I cannot simplify that expression any further, and so there would be my completely simplified polynomial. Okay, so that one is completely simplified. Okay, and so what you see here is when we were solving this polynomial, we conducted one type of factoring of polynomials, another type of factoring of polynomials, and then lastly, another type of factoring polynomial. So basically, we're putting together all these different types of different ways for factoring polynomials to get that polynomial in the very simplest form. So here, what we actually went from is we went from this expression to this expression. By completing 3 different steps for factoring polynomials. Questions? So whenever you're working through these types of problems, you kind of want to identify what are all the different ways I know how to factor these polynomials. And then when you're going to go ahead and factor a polynomial, you want to see, can I apply this way of factoring polynomials? No. Okay, move on to the next one. Can I apply this way? Maybe. Try it out. So you want to use as many steps for factoring polynomials to get it to the very simplest form. Okay. We'll go ahead and look at one more example. Oh, that's where I am. That's where I am? Yeah, hold on. Let's try this one right here. Okay, so again, I want to factor that polynomial completely. So I want to get it to the very simplest form. So this is a polynomial I'm going to work with. Hold on. This is the polynomial I am going to work with. Right here. Okay. So first thing I wanted to see, do I have a greatest common factor? That's normally going to be your first step. It's probably the easiest step. See if you have a greatest common factor that easily comes out of this. And so here I do. I can take out 5x squared. I can take out 5x squared. That means what I basically can do is I can multiply this by 5x squared. I can multiply this by 5x squared. I mean, divide. I can divide this by 5x squared and see what I get out. And the answer is 2x squared plus x minus 21. So you can see I've already created a much simpler expression of my original polynomial by just taking out 5x squared. Okay, so now I have here. Now what I want to see is there any way for me to factor this smaller? Let's remember our x method. This was our x method. Oh. This was our x method. So what it multiplies together, a times c. So 2 times 21, negative 21, is equal to negative 42. Now b is negative 21. Okay, so that's where I am. I'm looking for on one side what is multiplied together to give me negative 42, and one is added together to give me negative 21. Okay. Oh, This is B, sorry. Not C. B is 1. Right, this is your B. B is 1. Okay, so now I want to know what factors are multiplied together to give me negative 42 and added together to give me 1. So multiply together and add it. Okay, oh, this. So basically, if I have negative 6 times 7, I get negative 42. And if I have 6 plus 7, I get 1. Right, so I'm looking for factors that will allow me to multiply together to give me my A times C, which is negative 42, and add together to give me my B, which in this instance is 1. Okay, so now I can go ahead and write this into my original expression. And that, what I'm doing is I'm breaking apart B. So negative 6x, 7x, minus 21. So what I'm doing is I'm taking this original B, plugging this in right there. Okay, now what I have is a 4-term polynomial, which means what I could probably do is take out a greatest common factor. So I'm going to split those up. Okay, now I want to go ahead and see, do I have any further greatest common factors? Can I go ahead and simplify that further? Well, here I have a whole number. Here I have a whole number. Let's see if they have greatest common factors. Well, this is a prime, so 2. 3 and 2. 3 and 2. What do they have in common? That 2. So that means I can factor out a 2. This expression also has 2 x's, x here and an x here, so I want the smallest of those 2 x's. So 2x. Okay, so that is my factor of that first expression. Now let's look at the next one. There's 2 whole numbers, 7 and 21. 7 is actually a prime. What do they have in common? They have that 7 in common. I'm going to factor that out. They don't both have x's, so I'm not going to go ahead and factor that out any further. Okay, so this is where I am. I want to see what do I have to multiply together to give me my original expression. So from here to here, how do I get from there to there? Well, I can multiply an x. An x minus 3. Here, same thing, x minus 3. That's how I get from there to there. Okay, I want to put together common ones, so I have both of them have x minus 3. And then add together those that aren't in common right there. And then I don't want to forget what I originally factored out, which is 5x squared. And so there is my simplified expression. Okay, and so here what I've done is I've conducted 1 thing, 2 things, and 3 things. So I've conducted 3 ways of factoring this polynomial to get it to its very simplest form. Okay, so that's basically what you're doing. If it tells you to factor the polynomial completely, in these types of questions, you're looking for the key term completely. Then what you want to do is you want to go ahead and factor it to where you can no longer factor anything out. Okay, questions? Okay. All right, so a polynomial is factored completely when it is written as a product of a prime polynomial. So once you get it to the very smallest form, that is when you're factoring completely. Okay, so the first thing you want to do is see if you can factor out the greatest common factor of all terms. So see if there's something that I can take out that will allow me to take the greatest common factor of all terms. So for example, here we can take out 5x squared from all terms. So that's the greatest common factor. Consider the number of terms in the simplified polynomial. If it has 3 terms, then you're likely going to have to use the x method. If it has 4 terms, then you likely want to go ahead and see if it has any other greatest common factors. Okay, factor based on the number of terms, and then at the end you can check your solution, so you can kind of multiply that solution back again and see if you get to your original expression. Okay. Okay, I will go ahead and upload a simplified version of this. But if there's no other questions, you guys may log off, and I will see you guys tomorrow briefly. Bye, guys.
Bye, Miss.
Bye.